One of the applications of the scalar product is to compute the work done by a force. The work done by a force F in moving an object is given by W, which is the work done, equal to F dot D, where D is the displacement vector. How do we make use of this? Let's look at one example. Example: a force of 10 Newton acting in the direction of the vector I plus 2j minus 2k displaces an object from the point P 1 0 minus 1 to the point Q 2 minus 1 minus 2. Determine the work done by the force. First, we must get hold of the force. So this is a solution. Find out the force. So first of all, the force is in the direction of I plus 2j minus 2k. So you can write this is the direction of the force, I plus 2j minus 2k. However, this is not a unit vector. So you divide it by the length of the force. The length of the force, let's write down first. Then we calculate. Now, what we get is a unit vector. That means that this is a force of 1 Newton. Now we need a force of 10 Newton in the same direction. So you multiply this force by 10. So we have calculate the force. Let's try to calculate the length of this force. We know that the length or magnitude of A1I plus A2J plus A3K is actually equal to square root of A1 square plus A2 square plus A3 square. By doing this recall. So the length or magnitude of I plus 2j minus 2k is equal to square root of 1 square 1i, 2 square for 2j, and plus minus 2 square for 2k. So this is 4 plus 4 plus 1 is 9. Square root of 9 is 3. That means the length of the vector is 3. So now we know how to find the force. The force F is equal to 10 times I plus 2j minus 2k divided by 3. Having done finding the force, now we are ready to find the displacement. The object is moved from the point P, located at 1 0 minus 1, to Q, which is 2 minus 1 minus 2. So the object is moved from the point P to Q. And this is the displacement. How do I find the displacement? The displacement in this case is the vector PQ. How to find the vector PQ? This is the location of endpoint Q minus location of the point beginning point P. So OQ is the vector 2i minus j minus 2k, where O is the origin, and OP is the vector I plus 0j minus k. 1 0 minus 1 is the point P. So when you take the difference, you get 2i minus I, you get I, minus j minus 0j, you get minus j, minus 2k minus minus k, you get minus k. So this is the displacement D. So once we have the displacement D, we are ready to find the work done by the force. The work done by the force is given by the dot product or the scalar product of the force and the displacement. We have found earlier the force is 10 over 3i plus 20 over 3j minus 20 over 3k, and the displacement is I minus j minus k. So when we do the dot product, let's collect them. 10 over 3 times 1i. 10 over 3i dot with I, you get 10 over 3. Then the next one is 20 over 3 j dot with minus 1j, you get minus 20 over 3. And the third one, minus 20 over 3 dot product with minus 1, you get 20 over 3. So add them up, you get 10 over 3. And that will be the work done.